Hello again, we are in chapter 14. This is a continuation of what we started in chapter 13. In chapter 13 we saw that we could accelerate certain programs when the fitness function takes a long time and occupies the CPU. We can parallelize it, and we showed a couple of easy ways to run the program in parallel within your computer. But now we want to see if we can go outside our computer and take advantage of computing platforms that are out there. The first thing we're going to do is divide the program into parts, client and server. The server will be eventually running anywhere we want. We will start by running it inside the same computer, but eventually we can put it elsewhere. And the server will be the one that calculates the fitness function, which is most of the CPU in many cases in the examples that we have. The client will be actually running the genetic algorithm, and whenever it needs the fitness calculation to be done, it will ask the server to do that. And what we will see is that the client will eventually employ asynchronous I/O, which means that when it sends a request, it doesn't wait, it doesn't block until the response comes. It can go and send another request, and eventually when the response comes, it will process it, etc. And the combination of these two things, the concurrency on the server and the asynchronous I/O on the client to communicate with it, it will give us the acceleration that we want, or at least we hope so, but we're going to see it running. So if we go back to our files, we will see that here the setup is a little bit more complicated because we have the client and we have the server. So when we go to the chapter 14 files, we see the client files here. And then there is a folder called server that contains the server files. And to make the separation better, because it could run on two different computers, the libraries, the dependencies are very different between the two. For example, the genetic algorithms dependencies are only needed at the client. The server just calculates a fitness function. It is not aware of the entire genetic algorithm. And the server has other dependencies that are not really necessary here, and it could also run elsewhere. So we have a separate, or at least I would recommend to create a separate environment on the server. So we have two environments. We have the virtual environment, the same one we've been using the whole time, will run on the client side. And in the server, we will create a new virtual environment and use the requirements that are listed in this file, which are very different from the requirement that we used to create the original virtual environment that runs on the client now. And therefore, we will have two separate environments. And also, as you see here, I have two separate windows. One for the client side, where you see those where I'm going to run these files of the client, and the other one, I took this server folder and I opened a new window and I opened it there. And in the server, as you can see, let me delete that because we don't need it yet. In the server, I created a Venv server. I called it that way. It's the virtual environment of the server that has the requirements server deployed into it. You can do that either manually, or you can just install all the pip. You can run the pip commands manually, but I recommend to use the requirements file onto that environment. This is explained a little bit more in detail in the README file. And now we have activated that environment on this instance of or this window of the code IDE, and here we have the other one. So let's look first at the server. And what we did here in the server, we created a Flask application, a very simple Flask application that we call Fitness Evaluator. And what this application does, it calculates the fitness function. And as a Flask is a framework that enables us to create web applications very easily. And all this web application does, it will run up there on a certain URL, which will be local to this computer when at first. And it has two routes. So the root, if we just call it with the root into that URL that it runs on, it will just print back something like this: welcome to our fitness evaluation server. But if we go and use the route that's called OneMax Fitness, and then we will give it a string that represents the individual, which is the ones and zeros, it will convert that string to an actual number and calculate the sum of the digits. But it also has the same busy wait that we had before to make it just like before, to make it take 3 seconds as a busy CPU using the same busy wait function. So this emulates or implements the exact same fitness function as before, but it's now going to run in a server by itself. And we are going to launch this server right here. So the command to run this Flask server with that application, we are going to the exact same folder where the server is, and it's Flask --app fitness evaluator, which is the name of this Python program, and we follow by the command run. And when we do this, Flask server is coming up, and it's telling us that this is the HTTP that it's running on. So we can actually take this URL. This is a local host as we know it, and we can manually just test it quickly. If we just go there, we see welcome to our fitness evaluation server, which is the root. And if we go and try the other route that's called OneMax Fitness followed by some numbers, we will be able to see the response. So for example, our application has 10 digits, but the fitness function really does not care how many digits. It's going to return the sum. But what you'll notice is that it takes 3 seconds to return the response, and the response here is 5, which is the sum of those digits. And if I do this again, it will take again 3 seconds before we see the response that it's going to be 6. So the Flask application is up there. So coming back here, actually, we can see that whenever we call the Flask application, it is written down here as a debug information. We can see the 2 calls that we made. And we can also see timestamps, which here were far apart because I didn't send them right away. I was talking in between. Now let's go to the client side. So I'm going to the other window here, and I'm looking at this program. Let's close this and look at this. The OneMax client is where we are now just having we have the base URL. The base URL first is where we're going to use the application. And what happens here is that we replace whenever we want to calculate the fitness function, we are using this function, which is a client. So the client here just does a very simple URL open call, and basically is asking the server to calculate what is the fitness. And we know that the server will take 3 seconds to do that. And once the response arrives, it makes sure that it was 200 and not something else. And then it converts the response eventually into an integer. So that's really the only difference from before. We have the fitness function calling the server to return the response. So if we run this, what do you think is going to happen? Well, what's going to happen is that it's going to wait 3 seconds on each request and then send the next request. Wait 3 seconds, send the next request. And it's going to take a long time, just like the very original program where we didn't have any concurrency. and we were taking the time sequentially. Everything was happening one at a time. So this is going to be a sort of painful wait. We know that there are five generations plus the zero generation. So we have six times up to, and each one is up to 30 evaluations, but it's a little less. So we know that it can take something like 280 or 285 seconds for the whole thing to basically get done with the five generations. So let's just wait for it to finish. So finally we are done. We can see that it took about 285 seconds, just like pretty much the same as when we ran it in the previous chapter, the very first time, when everything was still 1 unit. But it did send the requests to the Flask server rather than calculate itself, and we can go to the Flask server and see the requests coming in with all the individuals, and we can see that they're 3 seconds apart pretty much. And every time it waits for the 3 seconds to expire or to do the job, and then it will send back the next request, and then after 3 seconds it gets the response, the client gets the response and sends the next request. So this brings us to 285 seconds, which is sort of painful to watch or to wait for. So what can we do? Since the server now is capable of serving multiple requests at the same time, we don't want to send just one and wait for the response. We want to send one and continue sending another one. And this is done using asynchronous I/O. So we have here the next client that takes advantage of that. And if we quickly compare between the two, we will see first that we use the elitism async, because elitism is where we actually implement the genetic algorithm with the elitism approach, and we had to change. This is actually where the fitness is calculated, so we had to change that. We will look at that in a second. We use async I/O, and then we see here that the definition of the max fitness, it has changed, and there is some session, and we again call the same URL, but instead of using URL open, we use the session with the async, etc., and you will see more about it in the book. But this part of the communication differs, where we calculate this, and if we want to compare this to this is where the genetic loop, the main loop or the main flow, is implemented. You'll see that here we use async I/O and AIO HTTP, and we needed to make some changes here that are also more explained in the book, but the main difference is that we start a connector, we create a session, etc. Everything else is just indented. The difference is mainly here. So what happens if we run this client rather than the original client? So let's open it again, and let's run it, and still with the same URL. The server is still up and running, still there. It's waiting for new requests, so that it hasn't changed. We just changed the client. So now let's run it without opening a new window. And we can look at the server meanwhile, and we can see that the requests are coming several at a time. You can see it advancing a lot more quickly. And also here we can see that the generations are advancing a lot more quickly. Let's go back here, and we can see that this whole thing of waiting for the response before sending another request doesn't happen. There are a lot of requests on the same timestamp every time. So this is going way faster. It's about to finish, and as you see, it achieved a much better speed than the original. Now we can make this. We can make the server. This server is Flask, which, if you go back to the beginning, you'll see that it tells you that it's a development server. If you want to make it more production worthy, you would run it using a server like a gUnicorn, or you can even run it here using Waitress. That is a Python implementation. You can just run this fitness evaluation Waitress as a Python program, and it will do the same thing. It will launch the Flask application, but wrap it with a better server. Or you can run it on another computer. You can also deploy this Flask application to many cloud services directly. In each service has some version that it will allow you, some kind of service that will allow you to easily deploy a Flask application. But we will not do that, but we will do something maybe more interesting. What we want to do next is actually deploy a completely serverless implementation. So for the next stage, what we're going to do here is to use the AWS platform, the Amazon Web Services, and the implementation of function as a service that is called Lambda on that platform. The Lambda enables us to take a piece of code like the code that calculates the fitness function, and take just that function pretty much and deploy that by itself. Or it could be an application like Flask. There are ways, and you will see soon how we can take the Flask application and deploy it into that Lambda, and we will send the request to the Lambda service, and the Lambda service will instantiate Lambda instances that will calculate that fitness function for us and return it. And this has a lot of advantages flexibility-wise. We can scale it up as much as we want, up to some limit, of course. And we have very little. We don't need to maintain a server. We don't need to worry about configuration or maintenance at all. Of course, we do pay for it. The amount of work that we are going to do now is not going to really cost anything if we restrict ourselves to what we have here. And generally speaking, Lambda is not expensive until you start to do very heavy, serious things. So you should look more into that if you have real-life applications. But for our demo, it will be a very, very little computing resource consumed. So how do we do that? First, you need an account on AWS. You need to create a free account. You can go and get a free account. You will have a login, and you will have to install the AWS CLI, which there is a link in the book to this page that shows you how to install. So this is platform dependent. I'm running currently on Windows, so I install it from the Windows, and then you do some setup, and you end up with the two files that are called credentials and config. The config file is created by running AWS config, the command. Once the CLI is there, you can use it to create the config file. All this is covered by many places online and by these two links. So now that we have all this in place, we can go back to the server and use a library called Zappa that is now installed here. It's a Python library that is part of the dependencies that are part of the server requirements. And Zappa does the magic of taking a Flask application, or also a Django application, a Python web application, and do everything that needs to be done behind the scenes to turn it into an accessible Lambda function service. So all we need to do here is, again, in the same directory of the server, we are going to do Zappa init, and it will ask us some questions about environment, etc. We can take all the default answers because it can guess some of it by itself, and the rest is just default. This is a random bucket name. We can take it, and this is the name of the app, and this is an okay name to call it. This is basically the Flask app. And we can say no. And now it creates this configuration that is going to show here as a JSON file once we say that we're okay with it. So here is the JSON file. It contains exactly that. We can go manually now, and you can go into the Zappa documentation, and you can change and add all kind of configurations. But for our purposes, this is good enough. So what we're going to do now is deploy it to AWS, and because I have the credential file in place and everything configured, it knows my account, and it knows how to reach my account on AWS and create the services that it needs. So I believe this will be deploy, and now we can just call it dev, because you can deploy it in different stages or configuration. It's just a name here, and let's do that. And that can take a while. It uses AWS CloudFormation and other services to create all this infrastructure. So we're going to wait for it to finish deploying. So it's done. It didn't take that long. And now our service is deployed to AWS. So we don't have a server running on this computer anymore. But as you see here, when it says deployment complete, it gives us an endpoint URL. So we're going to take that endpoint and use that in the same client that we had before. Let's go to the client. Let's go back to the async client that we had. And instead of the base URL that we had before, that was the Flask, the local Flask. And now we have this. And let's try to run it like that. So here we can still see the results of the original client and then the local async client. And we can see that this is running, it's being responded to by AWS Lambda, and it's running quickly like it's supposed to. And we can see that it would actually, in this case, quite a bit faster than running it on the local machine. If we go to the AWS console home window, we can see some of the main services. The main services that participate in this implementation are the Lambda service, of course, but also the API gateway, which is the way that we reach the Lambda from the outside. And then you don't see it here, but there is oh, here it is. CloudWatch is a place where we can look at the logs. So if we go to the Lambda, it will be called the server dev. This is what Zappa call it, based on our choices in the JSON file. And you can explore here the different configuration that was done. That was created completely behind the scenes. We did not do it manually. The API gateway also called server dev here, and we can see if we go into the definitions that it's pointing to the Lambda. Basically everything that goes into this, as you see here, any request that come to this endpoint that it told us about goes into that Lambda. And if we had a lot of different requests, a lot of different routes in the Flask application, it would all be served by the Lambda that would just look at the route and decide what to do with it. And if we go to CloudWatch and look for the server dev log group, we will be able to actually see logs if we go into those links, and we can see some more about what's happening there. So I encourage you to go and do all that and understand better what's happening here, or even to modify and improve. So this is it, but one thing that you shouldn't forget is to undeploy. If you're done with it and you don't have anything else that you want to do with it anytime soon, I would recommend to do undeploy to the same name, dev, so you know that you cleared everything and you don't have anything that might cost you money that you don't want to pay. So I'm going to do that, and it's going to be deleted, and that would be it for chapter 14. I hope that was interesting for you, and I'll see you again at chapter 15.